Hey there, Algebra 2. We are going to work with rational exponents. Remember, rational numbers are fractions, so that means we're going to put a fraction in the exponent. I'm going to show you, I have my calculator up here as well, so I can show you how that works. So let's clear out all this mess that we had before. So we get 216. All right, that sounds fine. And we're going to take that to the 1/3 power. So how do I do that? I do parentheses after my caret. I do 1 divided by 3 and close it up and say, hey, there's 216 to the 1/3 power. All right, now, the truth is we're trying to take the cube root of 216. So we know this answer needs to come out to be 6. Okay, but I want to show you how that works. Now, that takes a little bit of time on the calculator. So what we're going to do is we're also going to review what are those rules. So you see in part B, we have the same base. So if I have the same base, that means I should add the exponents. So a half becomes 1, so this becomes 7. So just because you have this tool with the calculator doesn't mean that's the best thing to do all the time. All right, so we'll keep that handy in case we need to get something else, but zoom in over here. So the idea is that whatever we have in the index here, okay, that becomes the denominator. So the bottom line is we're going to work with whatever it is. So x, and it's going to be the power over the root. So we can't say that enough. Power over the root. So 36 is to the first power, but it's to the second root. 64 is to the first power, right? We have some unwritten ones in here, and we're going to take the cube root of that. So it's the 1/3 power. So part of this is just being able to change them back and forth. And since they're both exponents, then the order really doesn't matter what we do with it. Now, I have 5 to the 1/4. Well, if I check that out over here, 5, so caret, and 1/4 is nice. Remember, I can do 1 divided by 4. Okay, what would be faster than that? 1/4 is 0.25, right? So I could do 5 to the 0.25. Notice we get the same thing. So if you have 1/2, if you have 1/4, if you have 3/4, feel free to use those decimals. 1/3 we're going to have to use. I can't use 0.3. It's too hard to get those things in there. So if I can't do this one on the calculator, let's get that out of the way and get this nice and big. What else can I do with it? Well, I can't really do anything with 5 to the 1/4, but is it possible to write 125 as 5 to some power? And we sure can, right? 5 times 5 is 25, and 5 of those, so that's the 3rd power. So this is 5 to the 1/4, and this is 5 to the 3/4. Well, now that I have the same base, I'm simply going to add my exponents, so I get plain old 5, because I would get 4/4 or 1. Okay, so we started this chapter dealing with our rules of exponents, knowing that we needed them for this section here. All right, one thing that I mentioned earlier was we have the power over the root. So here it is again. So we have the power over the root. So it's a power over the root. In case you didn't write it down above, you probably want to have that somewhere. We're going to continue using it. But what we're saying is if you have this as a fraction, I can use the power first, or I can use the root first. So based on the number and the power and root, then we want to think about what's the best way to do that. Okay, so first thing we're going to do is just convert them. So in the first one, we got x to the 3/7. So I need x. It is to the 3rd power. We have to take the root, and the root is 7. So 7th root of x to the 3rd power. Now, if I give you a decimal, first thing we're going to do is change it out. So it becomes 1 over y, and 3½ becomes 7/2. So it's 7/2, and now I have it in the denominator as well. So it becomes 1 over y to the 7th power, and then I have the square root. All right, we're going to leave that for today, and then as we work on this in the chapter, we'll find out. Remember, we just did division, and I can't have radicals in the denominator. So the problem is y to the 7th. So we could clean it up and figure out that we need one more y. But for the sake of today in this video, let's just make sure we can change them back and forth. All right, so w to the -5/8. So that means I have 1 over w. The power is on top, so it's the 5th power, and I'm going to use the 8th root. And again, not simplified based on our radicals, but it is translated, and that's what I'm after today. Okay. So what about w to the 0.2? 0.2 is actually 2/10, which is actually 1/5. Okay, so we have to understand that translation, which in Algebra 2 we should be able to. So w is to the first power and the fifth root. Okay, so we went the fifth root of w to the first power, so it's not a big deal. All right, second line here. So all the b's. You're saying, all right, now that you can change this into the radical form, now I want you to change it to exponential form. And it's not a huge deal. So we got fourth root of x to the third. So I need x, it's to the third power, and the fourth root. So 3/4. How to know which one's which? Okay, radical form has the square root sign. Exponential form has an exponent. So we shouldn't get those mixed up. The second one, we have fifth root of y, and this whole thing's to the fourth power. Remember, that order doesn't really matter. I could do y to the fourth and take the fifth root. If it was a number, I would think more about it. But here we just need to change it out. So it's the fourth power and the fifth root. So we can translate those back and forth pretty quickly. And that's going to become very important when we go to solve with these exponentials. All right, can I combine them? Sure thing. We've been doing it. You did it from the second problem today. Second problem today, you had already done this. All right, so we're going to write this in simplest form. We got a whole mess, and it looks awful. But here's what we really have. We have x to the third power and the fourth root. It's divided by x to the second power over the eighth root. We know this bottom one's going to reduce, right? That's 1/4. Okay, so now I have x to the 3/4 divided by x to the 1/4. Wait a minute, isn't there a rule when I divide with the same base? Oh yeah, I'm supposed to subtract. So what's 3/4 minus 1/4 is 2/4 or 1/2. So I have x to the 1/2. So this would be simplest form. How else could you see this answer? The square root of x. Okay, so these are interchangeable. I would take either one. Okay, but obviously just getting x to the 1/2 is fine. All right, what else do we have? We have 3, we have a square root. Okay, so if we were multiplying these the way we did before, we would say that we, with addition, we can't do anything. With multiplication, we're like, well, I'm not really sure. But here's what we do now is say this is 3 to the 1/2 power. How did I get a half? Remember the index is 2. 3 to the 1/4 power. Since I'm multiplying, that means I'm going to add my exponents. So a half and a fourth makes 3/4. How else might you see it? 3 to the third power with the fourth root. Okay, these are the same thing. We'll continue to translate those. All right, number B. Remember, this is a point where if you're not sure, remember these indexes that are empty actually carry a 2. So this is x to the 3/2, and this is x to the 2/3. What am I supposed to do with these two numbers? Subtract. Okay, so 3/2 minus 2/3. What's the common denominator? 6, right? So this would be 4/6. This needs multiplied by 3, so it'd be 9/6. All right, it's still improper, so that's a good thing. So how many 6 did we end up with? 9 minus 4 is 5, 5/6. So it would be x to the 5/6. How else might it look? The fifth power and the sixth root. So either one of these based on what they want for the answer. Okay, again, x to the 5/6 is super duper. If it's multiple choice somewhere with somebody else, then it might be nice to know that those are the same. All right, so I see a base of 7 again. So I just have to translate these. So this is 7 to the 1/2. This is 7 to the 1/3. Okay, remember there's that invisible 1 in here. There's an invisible 2 in here. What do I have to do with those? I have to add 1/2 and 1/3. So 1/2 plus 1/3. We're going to make those into sixth as well. Okay, so it's 3/6 plus 2/6. So we're going to get 5/6. But 5/6 isn't the answer. Remember, that's just the exponent. 7 to the 5/6. How else might it look? 7 to the fifth power with a 6 root covering it. So we can translate those back and forth relatively easy. That's the goal anyway. All right, so now we're going to write these in simplest form. And I tell you, this This square root sign here, this messes some things up. So if you needed a break here before we do this one, go take a break and then come back for it. Okay, because remember, we're going to take 2/3 of 8. We're going to take 2/3 of x. And then what I'm going to do is I'm going to rewrite this thing right here as the 1/2 power and then distribute that in as well. So here's what I need. I need -8 to the 2/3. I need x to the 2/3. I need xy to the 1/2, and I'm going to take that to the 2/3. That looks crazy. All right. So a couple things we have going on here. Let's get rid of the number and be done with that because I want to try and get that off the table here as the other stuff has a little bit more work. All right. So we can either take -8 and square it to get 64 and then take the cube root of it to get it back to 4, or I can take the cube root of -8 to make it -2 and then square it to get 4. So either way, it's going to be 4. Right? If you are using your calculator, make sure you put it in parentheses so we get that +4. So that part's taken care of. Next item here, I'm going to just bring down because these have to get taken care of. So 1/2 and 2/3, well, I end up with 1/3. So I have x to the 1/3 and y to the 1/3. Well, it seems like I have the same base right here. 2/3 and 1/3 makes a whole 1. So I have 4xy to the 1/3. All right, how else might it look? 4x and a cube root of y. Okay, so these start to get a little hairier, but we can handle that. And again, the final answer was right here. I'm good with that, but I just want you to see that it could be written in a different way. All right, let's try that again. So we're going to take 16 to the -3/4, and we have y to the -8 to the -3/4. Just trying to illustrate this distributive property that we use with our exponents, that just have to go to each. The next thing I would probably do to make this a little bit nicer is realize that I have a negative and a negative, so I'm just going to make those positive, so I'm not worried about it at all. And 8 divided by 4 is 2, so this becomes a y to the 6th power. Now with my 16, right, I can either cube 16 and then try and take the 4th root, or wouldn't it be a little bit nicer if I took the 4th root of 16 to find out it's 2 and then cubed it to get 8? Okay, again, this part could be done on your calculator. Okay, so we know that's going to turn into 2, but it has a negative, so that means it's over 2. So this would have turned into 1/2. So we're going to show that by putting the 2 in the denominator. So y to the 6th over 2. All right, so you get a preview. These are some things we're going to work on after we brush up on this in class. So if you want to work ahead on any of those because you're in my class, you can. If you're not in my class, that's too bad.